If you flip a coin and end up on heads, I'll give you $100. If you flip a coin and end up on tails, you get nothing. What's the expected value of flipping that coin? If you don't know what expected value means, you're probably confused right now. What do you mean? It's either $100 or $0. How can I have an expected value? Expected value just means the weighted average of the potential outcomes. Let's see what that means. There's a 50% chance that we end up with $100 when we flip the coin. There's also a 50% chance that we end up with nothing. So we have zero point 0.5 times $100 and zero point 0.5 times $0. That's $50 plus $0, and that's actually the expected value of flipping the coin, $50. So what does that mean? For every time I flip the coin, I expect to gain, on average, $50. If I flipped that coin 100 times, I would expect to get about 50 times 100, $50 times 100, because I'm flipping the coin 100 times. So the expected value of flipping the coin once is $50. If I do it 100 times, it's $50 times 100, which is $5,000. So this is what expected value means. It is the average outcome you would expect to see if you repeat an event many times. It is the average outcome you'd expect when you flip a coin for a certain amount of money, or when you roll a die, which will be our next example. What is the expected value of rolling a 6-sided die? Well, we just need to do the weighted average of the results. Each outcome has the same probability of happening, 1/6. And the outcomes are 1, 2, 3, 4, 5, and 6. So I have 1/6 times 1 plus 1/6 times 2 plus 1/6 times 3 plus 1/6 times 4 plus 1/6 times 5 plus 1/6 times 6. When I add all of those up, I get 3.5. What on earth does this mean? The expected value of rolling a die is 3.5. Well, that basically means that if I rolled that die 1,000 times, I would expect the average of the outcomes to be 3.5. If I rolled a die 1,000 times and I kept track of the results and then took the average result, I would expect it to be 3.5. Let's do another simpler example. Back to the coin toss. If you land on heads, I'll give you $100. If you land on tails, I'll give you $10. What is the expected value of flipping the coin? Well, there's a 50% chance that you get $100. So 0.5 times 100. There's a 50% chance that you'll get $10. 0.5 times 10. So you have $50 plus $5. The expected value of flipping that coin is $55. So what's actually happening here? What's the equation? You multiply the value of an event times its probability. That's just a fancy way of saying I'm multiplying $100 times the probability that it happens, 50%. Next, I sum all of the values. So there was a 50% chance of getting $100. That's 50. And there was a 50% chance of getting $10. That's $5. So when I add those together, I get $55. If I flipped that coin 1,000 times, on average, I would expect to get $55 per toss. So I would expect to get $55,000 if I flipped this coin 1,000 times. Now, if you've ever asked yourself, why am I learning this about math concepts? Pay attention, because expected value is one of the most practical math concepts you will ever learn. If you really internalize what it means, it will help you make better decisions in the future. It is the calculation to understand how the probability of an event affects its value. So whether you're just playing games with your friends and you're trying to win, or you're trying to understand financial situations in investing, understanding how to truly weigh risk versus reward comes down to understanding expected value. Let's say someone walks up to you on the street and offers you $10,000 guaranteed you can walk away with it, or says you can flip a coin and if it lands on heads, you get $30,000. Now, assuming that the coin actually has a 50-50 chance of landing on heads, which of these two options has the higher expected value? Getting $10,000 for sure, or flipping a coin for $30,000? Well, 50% chance of getting $30,000, that's 15,000, plus 50% chance of getting $0, that's $0. So the expected value of the coin flip is $15,000. The expected value of the $10,000 is, of course, just $10,000. So you wouldn't just be greedy to flip the coin and try to get the $30,000. It would actually be a mathematically sound decision because the expected value of the coin flip is higher than taking the $10,000. Now let's talk about an ACT question type that you might see. They might ask you about a fair game. A game costs $3 to play. You have a 10% chance of winning $5. You have a 50% chance of winning $2. You have a 40% chance of winning $0. Is this a fair game? Well, it costs $3 to play, so you're out $3. And then you have a 10% chance of winning 5, which is an expected value of 50 cents. You have a 50% chance of winning $2, which is a value of 1, an expected value of $1. And you have a 40% chance of winning $0, so that's 0. If we add the values together, the expected value of playing the game is $1.50, but it costs $3 to play. So on average, every time I play this game, I expect to lose $1.50. So this is not a fair game. A fair game is when the expected value of playing the game equals the cost. So let's take a look at a fair game. It costs $2.50 to flip a fair coin, meaning that there's a 50% chance of landing on heads and a 50% chance of landing on tails. That's what a fair coin is. If you land on heads, you get $5. If it lands on tails, you get nothing. Is this a fair game? Well, the expected value of flipping that coin is $2.50 because you have 0.5 times 5 and 0 times 0.5, which is $2.50. And that's the cost of playing the game. So the cost is the same as the expected value. And so this is a fair game. Quick recap, because this is a new concept for most people. Expected value is kind of like a weighted average. You take the probability that an event happens times the value of that event. Then you sum them all together. So you multiply each outcome by the probability that it happens and add them together, just like we did with all those examples of the coins and the die. If there's a cost to play the game, then you subtract that cost from the expected value. If subtracting the cost from the expected value equals 0, that is a fair game, and that is called the expected net value, or it might be called just the expected value of playing the game, might include the cost. So if the expected net value of playing the game is 0, that is a fair game.